You worry about the future of your species. Wars, climate change, pandemics. You imagine extinction as something that might happen someday, far off, avoidable if you're careful enough. But the real answer is far stranger. Your species already almost disappeared. Completely. Quietly. And almost nobody alive today thinks about it. Somewhere around 74,000 years ago, on the island of Sumatra, a volcano called Toba erupted. Not the way you picture a volcano erupting. This was far larger than any eruption in recorded human history, many times more powerful than history's biggest known blasts, like Toba in 1815. It threw so much ash into the sky that it dimmed the sun across entire continents. Near the volcano, ash piled up meters deep. Thousands of kilometers away, in what is now India, a thin layer of that same ash still settled over the ground. Farms today would struggle to survive a single season under skies like that. Researchers have proposed that global temperatures dropped by several degrees in the years afterward, though scientists still debate exactly how severe and how long that cooling lasted. Whatever the true scale, plants died back. Animals that depended on those plants died with them. And the humans who depended on those animals were pushed toward the edge of survival. How close to the edge? A geologist named Stanley Ambrose studied this question in the late 1990s. He looked at genetic diversity in modern humans and noticed something strange. Compared to almost every other species on Earth, humans have remarkably little genetic variation. Chimpanzees living in a single forest in Africa carry more genetic diversity among themselves than all 8 billion humans on the planet combined. 8 billion people, and less variation than one troop of chimps. That doesn't happen by accident. Ambrose proposed that the Toba eruption caused a genetic bottleneck, a moment where the entire human population crashed down to a tiny number of survivors. His estimate, by some readings, was staggering. As few as 1,000 to 10,000 people, total, scattered across the planet. Sit with that for a second. More people live on a single city block in Mumbai today than may have existed in the entire human species after Toba erupted. More people ride one subway train in Tokyo during rush hour than made up the surviving human race, by that estimate. You are descended from that handful. This idea connects to something scientists had already found a decade earlier. In 1987, a geneticist named Rebecca Cann, working with Alan Wilson and Mark Stoneking, traced human mitochondrial DNA back through generations. Mitochondrial DNA passes almost unchanged from mother to child, so it acts like a genetic breadcrumb trail, a thread you can follow backward through time. Their study pointed to a single common ancestor for all living humans, a woman who lived in Africa roughly 150,000 to 200,000 years ago. The media nicknamed her Mitochondrial Eve. She wasn't the only woman alive at the time. There were thousands of others around her. But she's the only one whose maternal line survived unbroken all the way to you. Every other line eventually dead-ended. Daughters without daughters. Generations that simply stopped, quietly, without anyone noticing at the time. That's not comforting. That's terrifying, if you actually think about it. Now imagine that same fragile thread passing through a volcanic winter. Through years of darkened skies and struggling food chains. Through a population small enough that a single bad hunting season, a single disease, a single harsh winter, could have ended the entire experiment of being human forever before it ever produced a single city, a single book, a single one of your ancestors' children. It didn't end. But by some estimates, it came close enough that scientists can still see the scar in your DNA today. Here's where the story gets stranger. If nearly everyone died, where did the survivors survive? An archaeologist named Curtis Marion has spent decades excavating caves along the southern coast of South Africa, at a site called Pinnacle Point. What he found there reframes the entire near-extinction story. While much of Africa was turning into freezing, ash-touched desert, this stretch of coastline stayed livable. The ocean regulated the temperature. And more importantly, it offered a food source most humans of that era had never relied on before. Shellfish. Marine's team found layers of discarded shells, evidence of a population that had learned to harvest the sea. Mussels, whelks, brown mussels pried off rocks at low tide. This wasn't luck. It required understanding tides. It required timing, patience, memory of which rocks held food and which ones didn't. It required passing that knowledge down, deliberately, from one generation to the next, long before anyone had a word for teaching. In other words, the thing that may have saved your species wasn't strength. It wasn't speed. It wasn't sharp teeth or thick fur. It was the ability to notice a pattern in the world, remember it, and teach it to someone else. Sound familiar? That's still the core skill keeping you alive today. Not muscle, not instinct. Information passed carefully from person to person, generation to generation, in something like the way it was passed down on that shoreline 74,000 years ago. There's real debate among scientists about how severe the Toba bottleneck actually was. An archaeologist named Michael Petraglia led excavations in India at a site called Jwalapuram and found stone tools both above and below the layer of Toba ash in the ground. The tool styles didn't change much across that layer. That's important. In Petraglia's excavation, that break simply wasn't there. The truth is probably messier than one single catastrophic story. Some populations may have crashed hard, or the toolmakers Petraglia found in India may have squeezed through relatively intact, protected by geography, climate, or knowledge others simply didn't have. But even in the more cautious versions of this story, one thing holds. At some point deep in your past, the population of anatomically modern humans narrowed down enough that its echo is still detectable in your genome today, tens of thousands of years later. Geneticists didn't go looking for a catastrophe. They found unusually low diversity first, sitting quietly inside human cells, and only afterward started asking what could have caused it. You are descended from survivors. Whether that population narrowed to a handful of thousand or held on in scattered pockets across the world, every advantage you take for granted today, city, language, agriculture, art, exists because those lines of people didn't break. Every person you've ever met carries that inheritance. Every stranger on a train, every face in a crowded city, every family member at a holiday dinner. All of you share a strikingly similar genetic thread, shaped by a bottleneck event deep in your shared past. In genetic terms, you are closer to nearly every other human alive than individuals of most other species are to each other. That's why human genetic diversity is so low compared to many other animals. Not because humans are simple, because humans are the descendants of something that came unusually close to disappearing. There's another detail worth sitting with. Bottlenecks like this don't just shrink numbers. They shrink options. When a population narrows down sharply, the survivors aren't a random sample of everyone who existed before. They're whoever happened to be standing in the right place, with the right knowledge, at the right moment. Every genetic quirk you carry, every subtle trait passed down through your family, was filtered through that narrow gate. You didn't just inherit your ancestors' survival. You inherited the specific, accidental version of humanity that happened to make it through. Compare that to many other large mammals alive today. Elephants, gorillas, wolves. Several of them show more genetic variation across their populations than humans do, even in cases where their current numbers are far smaller than the human population. That's the strange part. Population size today tells you surprisingly little about the depth of a species' genetic history. What matters is what happened generations ago, in moments no one was around to record, moments science only reconstructed decades later by reading the evidence hidden inside living cells. Think about that the next time you worry about the future. You come from a lineage that already faced the ash and the cold and a difficult, uncertain world, and adapted instead of disappearing. Not through brute force, through memory, cooperation, and the quiet, stubborn habit of teaching the next generation how to survive what you survived. You've been worrying about the end of your species, but your species has already stared down something close to its own end before, and it didn't survive by accident. It survived by learning, together, how not to.